All right, can I have your attention, please? Our next speaker is Michael Meeks, and he will be giving a talk about the scaling and securing LibreOffice Online. Please give him a round of applause.
Well, it's very good to see you today. Thank you. Thank you for coming and hearing about these exciting things that are feeding back on the microphone. Excellent. LibreOffice Online, what a wonderful idea. So, there are some people I talk to and they say, but this is old hat, it's easy. We are already doing it. We have LibreOffice in our browser. We've been using it remotely for years, and that's fine, right? That's great. And it's entirely true. People have done this for years. X11 is older than I am, almost certainly, and showing it. NX is doing a great job of this. VNC, Oracle and Olivetti Research made it. Citrix. Cloudon was a particular fan of ours. They were a customer, actually, of Collabora's, and they did a great load of work in LibreOffice that was really good. But they would actually record the screen on an Amazon VM and convert it to an H.264 video and play it on your tablet, thus bringing, Microsoft Office, sadly it was Microsoft Office at the time, to your tablet. But, this sort of idea is relatively new. iOS, Amazon Workspaces, lots of people doing this. But really what these guys are doing are cutting really very, very low in the stack. They're stealing pixels at this sort of level, right? So there's a whole lot of things the application knows and can tell this lower level that they just completely miss out on. And we'll have a look at that, how that pans out in a second. I should have brought my remote. Terrible, isn't it? So they do it, all sorts of clever tricks to make this perform nicely. So they try and work out what you have done and then do it more efficiently on the client. So they try and detect movements or changes to icons, to versions that they already had. So, hashing little bits of screen to see if there are already copies on the client, so you can reduce the bandwidth and so on. Trying to work out exactly what happened as you went between here and here. And it can take quite a while to do this. It's not terribly efficient. And also, it really needs to learn about the application to some degree. So it's fair enough to have cached versions of menus. So I think NX does this. When your menu pops up, it knows what was there last time. And it's got that on the client already, so it can do a much better job of, very quickly responding bandwidth-wise. But, this takes time. It needs to be pre-populated. Seeing around corners is hard. And one of the areas that's particularly hard is when you do a page down. So if you do a page down in your document, you suddenly get a big chunk of new content. And it just can't be seen that that's going to happen at this level. So you get a nice copy, and then you get a big hole, and it slowly fills with content, which is a shame. So seeing around corners is difficult. However, LibreOffice Online has none of these problems. So we can enable all sorts of even more clever tricks inside because we know what is down the page. Isn't that clever? So it's happening at a totally different layer of the stack. And that gives us just a huge insight into the document model. In fact, we don't even need to start the application in order to provide you with the pages that that we know are going to be there. As long as we've rendered them before at a similar zoom, and we don't even have to start LibreOffice up, we can just serve it straight out of the cache. And so we can do all sorts of nice things with life cycle, and we can see around these corners, and we can do just a much better job. That's the thesis, anyway. Look at that. So how do we do that? We have a thing called LibreOffice Kit. Kits were very trendy at one stage, I don't know, package kit, console kit, I don't know. We have a LibreOffice Kit. Inevitably, OpenOffice.org sounded like a good name back in the day. But maybe we'll evolve the name as we improve the software, who knows. This exposes the core of LibreOffice, so that those file format filters, the ability to render that content, and editing, so the raw core editing functionality, which I think are things that make LibreOffice outstanding and different in its class. It's an extremely simple header-only API library. Library. You include the headers, and it will DL open your LibreOffice on your system, and it will pull loads of goodness out of it. And you don't need to link against LibreOffice. You can have a very small application that compiles in a nice little box very quickly, like this. Really 5 seconds to compile LibreOffice Online sort of thing. It's not a massive job. And so that's pretty sweet, just being able to pull the pieces out that you want. So there's no sockets, there's simple initialization, there's really very little that you can screw up. And it's used by LibreOffice Online. It's also used by Android for doing the tiled rendering on Android. And there's a huge similarity between Android and LibreOffice. And Document Foundation did a great work. All of the donors to the Document Foundation helped fund work on making LibreOffice work on Android, which has been significantly reused here and built on top of. There's also a tool called LOConv, which is faster than using the command line conversion, which is interesting, really. We should speed up our command line conversion tools. But some people use LibreOffice to automatically batch convert documents, and that brings a number of problems with it. But it turns out using LibreOffice Kit is significantly faster. Oh, and we can use this actually inside LibreOffice Online. We have a nice little service that's quite cute, where you can send a little HTTP post containing your document and tell it what format you want back, and it'll convert it for you. So look at that, a cloud document conversion service. It's quite a useful feature, as we'll see later. So how does it all work? Well, I pointed out this side before. Of course, there's a client as well. So this is running in your browser, on your PC, or your touchy tablet, or whatever it is. And there's a chunk of HTML and JavaScript there, and it's built on top of Leaflet, which is a mapping widget. I'll stand still for the photo. Wonderful, wonderful. And Leaflet have a nice logo like this. And so we have a WebSocket between the two, which gives us very low latency. Which is very nice, and nice persistent connection. But sadly, we need HTTP as well for various corner cases of downloading things that browsers like to have as HTTP, which is a shame. Let me just see if I can give you a quick demo. Let me see if it's going to fly. So here is a CV for a graphic designer. Yes, I think I've mangled this at some stage in the past. So just to persuade you that in fact you can type into it, I'll type into it like this, and you'll see some pretty weird stuff. So in fact, although it's pretty easy to do stuff with images, this is a sort of custom shape in a weird, Microsoft document and so on. So this is pretty nice. And it's WYSIWYG editing, so you're doing real page layout actually in the document. Now, if you compare some of the alternatives out there, they can preview nicely as WYSIWYG. What you see is what you get. But as soon as you start to edit, they go into a different cut-down Java mode that doesn't really work, which is a pain. So what else can I show you? I can show you some search stuff. Let me search for TH, the GIMP. So I can come through this document, and so far I hope it looks to you like everything is text, right? I can select it, I can do this sort of stuff, I can make things bold and italic and underline them and all this good stuff. The keyboard shortcuts you're used to. And it all seems quite nice, and it's relatively snappy. Of course, it's snappy because it's on my machine. I'm going to have to persuade you it's reasonably snappy remotely as well. We'll go into exactly how this works, but one thing I wanted to show you was just to look at what's going on under the hood. So one of the things that's quite nice here is that Chrome, of course, has this lovely debugging thing. And what you can see immediately here is that actually, although this looks like text that you can edit and interact with and fool around with, in fact, it's a bitmap. It's a square 256-pixel bitmap. And next to it is another one, and so on. So although this seems to be a nice interactive, smooth, Office Suite experience driven with text, actually it's a whole load of pixels that are coming from, the other side of the world, which is pretty nice. One of the interesting things about that then is that we can scroll obviously very quickly as you scroll around the document. In theory, he says, look at that, that's absolutely terrible, isn't it? But you can zoom in and out. And you're going to get a nice behavior here, so that when you're on your tablet and you're pinching to zoom, you're going to get that 60 frames a second beautiful experience you're expecting. And you're expecting your browser, even your browser will do an incremental re-render of that stuff, won't it, as it happens. So that's pretty nice. What else can I show you? Why don't I show you a simple spreadsheet? I think I've got one here, just to even it out. I know Ike's in the audience here, and he'll want to see a spreadsheet, So here it is, Why not? And it's drawing a little chart, and you can fiddle with your, I don't know, make this 15, and your sine wave will go more wiggly, or you can make it, 20, and it's even more excitable. And you can see the formulae here, and you have a simple formula bar and headers and rows. I mean, it's extremely minimal editing environment. At least, to us, there's a huge value in getting this online and getting it available to everyone. Our plan is to enrich the editing experience much more as we go ahead, and I'll talk about maybe in a bit. So that's my demo. How does it work? Well, I think I showed you the tiles already, but LibreOffice Kit has this API, so it's C and or C++. We're very agnostic language-wise. The main two languages are supported. I think even there's some Python bindings. I think Michael somewhere writes beautiful Python bindings for them, if you like that, and perhaps others. These basic conversion operations, so you can load documents and save them in different types, simple stuff. But you can also start to paint tiles, and you get bitmaps out of them, of any size you like. And you can introspect the document, find out how many pages it is, what the size of it is, and so on. And you can switch between parts. So we try and pour all of the applications into one mold. So spreadsheets, sheets are parts, sort of an integer offset, and slides are parts as well. Then there's some editing operations. So you can post key events in, and mouse events, and Uno commands, and paste stuff, and all of that, the good richness that you can see there. And it's served by this server, a daemon, that basically manages and handles all of the communication there, and caches the tiles. And there's really two levels of cache there. So one is when you have the document that's actually saved, you want to be able to continue to see that, and then you also want to be able to see the editable version. So there's kind of a bifurcation there between it. And then we have a very simple protocol. It's extremely simple. We have a WebSocket, which you may or may not know is a binary protocol underneath. And on top of that, we layer a text protocol, astounding in its simplicity. So you can load various pieces, pass URLs, invalidate areas, so ask them to be re-rendered, and fetch tiles and so on. Push key codes into the server. So yeah, and if you've got a big binary blob, you send a new line, and there it goes. Leaflet is originally a map library, so your document is actually a map. Isn't that good? And I think the map library has all sorts of code for sort of doing spherical something or others that we turn off, because documents thus far are not mapped onto a globe. But maybe one day, we'll have spherical documents, and then we'll be able to, do more. I don't know. So this uses tiles as well, and it's just saved us a lot of work with the infrastructure, so we can get there quickly, do all those gesture and pieces there. But then there's, of course, lots of work on top of that to do the editing as well. So if you look at your document, obviously there are a lot of things that change in your document, and we don't really want to be redrawing tiles on the other side of the world just when we select text. It would really suck if, as you moved your cursor, we'd have to draw new tiles and then send them all over the world, and this would be really silly. It would be really dumb, right? That would be monumentally awful. When you consider the remote desktop case, that's what they're doing. It's really that bad. You send your event, and it comes back with a picture of a selection that got bigger. And you'll discover this kind of interactive behavior is relatively rare in these things. So we don't do that. We send very small messages with the coordinates of, for example, where the selection is. And these handles are then rendered in a layer over the top. So there's a nice SVG layer sitting on top, and blinking the cursor like this, and there's no bandwidth used to blink the cursor, which is quite useful. Presumably, on the alternative side of the world, every time the cursor blinks, a message goes across the server traffic, and a picture with it if you're not careful. So, selection handles for resizing shapes and so on in the document, the same story. Cursors, cell cursors in calc and so on. So there's a few of those, and perhaps more of them in future for table manipulation. I don't know. We'll see. So it all looks good, but there are some interesting problems underneath. As you may have seen, my talk is more about the problems than the solutions, but let's see. Maybe it's got some solutions too. So here's my goal. I want to get about 1,000 concurrent users on a largish machine, okay? So 32 gig of RAM seems like, well, it's quite a small amount of RAM for a largish machine if you're really into big machines. But, it seems reasonable. So the nice thing about having 1,000 users is it makes it very easy to divide your gigabytes into megabytes and so on per user. So that's 32 megabytes each. And the corollary of this is pretty simple. That if you can share something across multiple users, you get a 1,000-fold memory win out of it. And that's kind of useful, So if you can get this string shared in both processes, or this page shared in both processes, we save really a lot of space. So our 4K page becomes a 4-byte page, effectively, per user, right? So we want to do that. And of course, everyone tells you should never optimize before profiling. I tell people this all the time. So after a bit of optimizing without profiling, I decided to go and profile the thing and discover that what I was doing was completely useless. So, some people never learn, but you could. So, don't optimize before profiling. So I fired up Massive to look at where our memory use is, and this is a tile bench. It's just a little program that benchmarks rendering tiles. And I was pretty convinced that the strings would be the problem. I think the strings may be in green or something like this. And actually, it turns out this huge red thing is the problem, and there was just some horrendously stupid Kyrie manipulation. And so, within a few minutes, we saved 8 megabytes a user, and with another few, 5 lines of patch later, we were down from 38 to 23 megabytes a user, and there's still some huge just fail going on here in the background. So LibreOffice Kit is a nice API, but behind it, you need to understand there is a LibreOffice, and it is being trained, it is being remedially educated in good behavior. But still, it likes to create big windows that you can't see and then draw things into them if you're not careful. And so this, I think, will also save some CPU time, which is good. However, I mentioned the sharing thing, and it's worth then understanding that inside this sort of web service daemon box, we work quite hard to share memory. So there's a thing called a broker daemon, and what we like to do is do a thing called, if you've used KDE, it has a thing called KDE init, that reduces the link time for the C++ apps it launches, but also shares a lot of memory between them, which is great. We want to do something similar. So we have a broker daemon that spends its life just sitting there spawning, forking worker threads. So it comes up and initializes lots of things and stashes all of that hard work away so that you don't then need to take the CPU time and worse, the RAM in each of these processes. And we'll look at some of that in a second. And you have all of these LibreOffice Kit processes here sitting around, entombed in a jail, a CA-true jail. And they make tiles which are then served out to the wild world down here, which is great. So we looked at then the heap to see how much heap was being burnt for pointlessly. And this is after the several easy wins. There's still a chunk of stuff here in red that can be immediately pulled out, I think. It's just about 9 meg of waste per client there, just allocating bitmaps we don't need in the drawing layer. But beyond that, it's looking pretty good. So, after we pull those out, which I think is, again, probably an hour-long hack, 14 megabytes, of which about 12 megabytes are shareable. So we should be able to share a whole load of strings, or much of the configuration. Actually, the strings live in, the strings I split out here. And things like UI icons. Like, why are we, spending money and time loading UI icons? There's various bits of silly things there. And the service stuff as well we can save. So there's various registries for internal components. So I think that with only a day of work or so, we can get this to sort of under 5 meg per user, which is encouraging. Of course, let me talk about the strings. So one of the nice things about our strings is that we control our own string class, which is very elite. And we have a elite hack here, which is that the reference count is not just an atomic reference, because it's got to be work across threads. But this is an immutable string. So every time you mutate it, you allocate a new one, which is exactly what we want if we're going to share the original strings. And also we have this bit flag on our, some bit flags at the top of the reference count. The lowest one of them is called the static flag. So if you keep referencing your string, as you could, like take 1 billion references to your string, eventually you hit the static flag and you don't ever wrap around your reference count, which is quite useful. And subsequently, you never touch that page again. Because the worst thing to do is to allocate all your strings, pack them all into a page, and then immediately start touching it for no reason, writing to it. This would be really stupid. So we should be able to allocate all these strings and then just staticize them all and have all of the basic data set that we need in a single page, single chunk of physical memory there on all the nodes and of course read-only, which would be great. A better way to waste memory is with ELF linking. Well, I don't know. It's a good way to waste memory. So the FLOSS ecosystem has this wonderful habit of just creating hundreds of libraries. Why have one library for glib when you could have 5? Why have one for GTK when you could split it into several other small libraries and link them all, and then have some plugin libraries as well, and so on and so on. And each of these libraries, unfortunately, wastes memory. So you need all of this this global state that's there, and we can get rid of some of it by using ld-bind now at the bottom. So the symbol pieces we can share across all these processes, but unfortunately, the global data we have to initialize, and it's not going to work nicely. And the LibreOffice you see now in front of you is using something like 200 or so of these shared libraries. 211, I think, at the moment, of which almost certainly most of the, these sections are wasted. But, it's only 800K, but it's still worth getting rid of, It's not, I'm not liking our budget. Also, we're using a whole load of pages. So, I mean, 88 meg is really quite a lot of 4K pages. So the poor old kernel, I'm hoping that it's not generating page table entries for all of these things for each user. I imagine it's doing something terribly efficient internally. But there's quite a lot of them, embarrassingly many. It would be wonderful if we could use 4 megabyte pages instead. It would help our TLB accesses, and life would be a lot better. But I think for linking, that's a really big ask. We'll see. Maybe we can. Maybe there is some kernel engineer, kernel hacker, glibc person that has crept in here today that is going to fix this problem for me and make everything more efficient. Of course, we could link everything into a single blob, which at least helps reduce quite a lot of these wasted, fragmented library things. But yeah, it's pretty nice to be able to reuse your existing PC product with exactly the same code you use on your PC for LibreOffice Online. So you're supporting one binary, some one configuration, it just renders stuff differently. Well, the same, but using different API methods for desktop and server. So, maybe we get to pay the cost. Here's a look at just some PMAP outputs, so looking at the proportional set size, which tries to work out how many users of a page there are, and then sort of divides the cost up by as many users as there are. Measuring memory usage is pretty tricky business. So before we did this bitmap optimization, it was quite a lot per user. As you can see, just stopping doing stupid stuff helped quite a bit there. There are various little hacks along the bottom, but pre-init is essentially using this broker process to initialize as much as we can in LibreOffice before we fork. So it's all those pages can be shared. There's much more work to do here in terms of staticizing those strings properly and so on. And there's lots more things we can do there. So you could imagine, for example, if the glyph cache, when you render glyphs, they turn into pixels, and we cache those. Well, at least we should cache them. I think this is now inside Cairo after quite a long sterling work. But you should be able to cache those for all fonts at all sensible sizes ahead of time. So you take another 5 seconds to start up, but then you have this massive shared blob of rendered glyphs that you can just stamp very, very quickly, which would be nice. So there's more we can do there. So less than 5 megabytes of heap for Hello World. But Hello World is not a very good document. It's not very big. So what about 100 pages of text? So, for 100 pages of text, and this is just the demo text, F3, filled out and pasted down, we get something like 1.4 megabytes, which is pretty cheap, I think. Now, of course, if you're going to paste huge images into your document and embed, monster movies and DVDs and so on, which you can do, it's going to create a problem. Ultimately, we're going to need to limit the memory that each user can consume. But my hope is that it's quite feasible for documents. The other problem with browsers is that, I don't know if you use the browser like I do, but I just carry on opening tabs endlessly until something gives. And the browsers have got wise to me recently. They've started to close them silently without telling me, sort of like 20 down the stack or something. But usually I notice my machine starts to grind to a halt, and I think, oh, I better kill Chrome again or something, And that's great, it's a very nice life cycle mechanism. Unfortunately, when this is in the cloud, it's the collective experience of the world slowing to a halt is probably not one that we can afford. So the nice thing, of course, about how we run this is that we can be pruning these processes and saving these files down in the background. So as soon as you're switching away from the tab, we can notice that actually you're probably not interested in this document after a few seconds or minutes of not coming back to it. We can say, that's idiot Michael opening another tab, one for each document, and we'll just pull that document out, yank it out. And at least we'll stop sending him updates for his document. He can get a full refresh when he comes back to it, if ever. And so any experts in scheduling algorithms that want to, sort of balance the available memory versus the number of users versus who saw a page last versus whether it's focused versus, this is some research papers here that you could publish. And of course, generic remote desktops really suffer here. If you're going to have a generic remoting solution and you've loaded lots of desktops and lots of desktop apps, they're not really designed for this kind of checkpoint, save, restore thing. I mean, you can do virtualization and then, serialize this huge whack of memory or something. They're not very clever. It doesn't, I don't think, work very well. So we have a huge win there from being able to lifecycle manage these on the server. So that's the whole memory story. What about load? So CPU load is another obvious important aspect of scalability. Here is I don't know if you can see the soffice.bins, but there's quite a lot of them down here. And 1,390 sleeping processes. I like this, So this is actually a live session in Largo, Florida. And why do hardware vendors invest in ever deeper sleep states? The power off the server sleep state, Well, it turns out that loads of servers and things out there are basically not being used. The computer is too clever, It's not doing anything. Of course, unless it's, Norbert's build server that is churning Libreoffice builds back to back, at which point the machine tends to melt itself into a heap and die after a while because it's not expecting load. So anyhow, this machine here with that spec has something like 800 active users, of which 150 to 200 are concurrent. And the load average, as you see, is 0.6, 0.8, 0.7, which seems reasonable. And they're using X11. It's not exactly our use case, but I think, well, I'm trying to persuade you that this is not a huge problem. There's also been some great work here to improve things. We're using a thing called Vigra for doing our pixel bashing. It's actually horribly ugly, aliased, unpleasant, giant C++ templates, impossible to read and debug, and surprisingly inefficient despite all of that. So we did quite a number of fixes. One of them I particularly liked was, you have a 1-bit mask, and it's big because we're going to use it for clipping. And it's iterating there, doing bit masking operations to set each bit to 0, like all the way through. Not very clever. So we got some nice wins with just sort of mem sets from that gave huge speed ups. But now, thankfully, Quaylon has converted it to use Cairo, which is awesome. So now we have actual real hardware accelerated assembler fallbacks for all these beautiful anti-alias rendering pieces. So thanks Quaylon. And that happened after several of my screenshots and my demo, so it's not in this live code. So if you see something horrible, it's probably gone already. Okay. Bandwidth. Okay, so bandwidth is another thing, and it's can be somewhat expensive. This is the back of the envelope calculation for the manic typer. So it's possible that somebody spends half of their time actually typing like a typist, transcribing stuff. And it's possible they do it in a way that damages multiple of these 256 pixel tiles. Obviously, that doesn't necessarily happen very often. Text can rewrap around the line, but I don't know. It's an estimate. And if you spend half your life actually typing, the compression ratio is based on some tests we did around text. Often, you have a simple white background and you have black text with some anti-aliasing around it, and this seems like a reasonable ratio. These are your tile sizes, and you come up with this raw bandwidth requirement per user of something like 270 kilobits a second, which for those of you who started on a 64 kilobit modem, like me, if you were lucky, seems a lot of bandwidth. But in the modern world of waste everywhere, this is about 7,500 users on a 2 gigabit a second connection, which is a reasonably good number of users, I would argue. Particularly since this is a highly under-optimized from a bandwidth perspective as yet. So NX, who do I think something at least comparable, claim they need 20 kilobits per user, kilobits per second per user, which is about a tenth of my inflated estimate. So, there's an argument that you don't need to see immediately every one of the key presses that you type 3 in a second on the screen as you press it. So you can, perhaps avoid some things there. We're also sending, complete 256 pixel square tiles instead of deltas. So, something simple like moving from a big thing to a remarkably smaller thing, that is the glyph you just typed, should give a really nice factor improvement. I think there's a lot of scope for fun work there to shrink this down and get some kind of 10x win. Ultimately, I would quite like to see the glyph cache on the client and not on the server to save us memory, and also to hide some of this latency so that you press the key, and we have already predicted what glyphs we should be putting where by the time the key is pressed, so that we can be stamping it straight on the screen in the client, and letting the server rest like it likes to. So yeah, lots of fun optimizing to go on that. So security, I've got a few more things later about what we could use help with in this area. But basically we have what's arguably a layered approach here. So inside the box you have a scary LibreOffice kit, a rendering instance, and with the best will in the world, eventually they're going to bust through all of our hard work and get out. So we're pretty scared of this guy. He has a dodgy document inside himself. But having said that, we have the an incredibly good covariety score. How much this means, I don't know. But we do some pretty aggressive fuzz testing. I don't know if you went to Quailon's talk, you could have seen it running for weeks and weeks, trying to find ways to break out of the box. And my hope is that if we use the best tools and we throw enough hardware at it, we'll be approaching a step ahead, at least of the script kiddies. So we're beating the, almost any other project's covariety score. We do a whole load of load crash testing. So we regression test our 55, 65, 75,000 documents very regularly in a tight loop, thanks to Marcus, who's fallen asleep. But never mind, these things happen. And we have then we inside, outside all those sort of basic trying to make the software hard pieces, we then have a chroot per document and per user so that this thing is isolated inside a chroot. Inside that chroot, we have a very, very sparse file system because we don't want anything bad in there that you could use to do something even worse. So, there's no, there's no shell. There's no, it's just very, very, very minimal. Which is good because that saves resources and inodes, when we're having thousands of documents open to. The thing I'd really like to find someone who would like to do is to implement seccomp BPF so that we can cut down the set of system calls that you can use so that ye olde weirdo system call that is not used frequently and it might have a vulnerability, that we can further shrink, the number of entry points there. And of course the document data is specific to the chroot. So your document is only living inside this guy. So, there's obviously no access to anything else. And then, of course, we put it inside a virtual machine or a Docker container, so you have that extra layer of protection. Nothing's perfect. And then put it on my computer, you bury in the ground and turn off, and then it might be perfectly safe. But either way, I'm optimistic that we can do a good job of damage limitation. Because our friends at Google say they get some very strange documents that have been crafted to, do odd things. So here we go. The web browser itself provides a number of opportunities for improvement, which are probably worth looking at now. So LibreOffice is a pretty powerful piece of software. It runs on almost every operating system you want to think about, and integrates with lots of copy and paste functionality, but the web browser really takes the biscuit. I mean, in terms of API surface and what we can do, sadly, at the moment we can only copy plain text, which is a shame because we have all of this rich semantic information. We have charts, we have spreadsheets, we have formulae, we have rich formatting, all this sort of thing. And here's how we do it. I mean, even the text is not easy. So what we do is, when people select stuff, we wait for the selection changing to stop. So, the text has been selected. About 300 milliseconds or so. So, if you're a ninja, you can break it, Control-C, Control-V, and it won't work. So, pause after your Control-Cs. And then we fetch the text from the remote thing into a member variable because we need this later when we're going to do a paste, or do the actual copy, rather. Because it's not, you can't actually fetch that during the copy callback. As you touch the Control key, we create a hidden text area. It's absolutely wonderful. And we select the text inside it and focus it so that if we're going to get a copy, if they press Control-C, we will then get the event we need. So there's a nice little hidden text area with dummy text in it. And then we can get the copy event. And we can fill it with the text that we've stuffed away in the member variable here. Okay? Don't you love it? It's absolutely brilliant, isn't it? Anyway. 1.2, paste. Yes, so we don't have to pre-populate the text area here. We just have to mash stuff into it. So, that's okay. And it's possible that we can do a better job here because, we're on the receiving end. We actually get text of potentially different types, which is great. So we can notice it's arrived and push it and then fetch the new tiles and show it. But the slightly sad thing here is that with the right API, we could copy and paste just very richly. It's my dream to have the Microsoft Office on one side and the text selected in it and paste it into the browser, and It just works, and it looks beautiful, and it retains all of the content. You know, and we're working hard on the filter piece, but we need the API surface to do a good job. And really, a copy and paste API needs several things. Basically, it needs content type negotiation. So you can say, I'd rather not have text if you've got something better. You know, what about, you know, RTF or, you know, something else, HTML even. And we also need the ability to do real work in the copy event handler. So, you know, that means remote process, you know, remote RPC. And I guess probably the problem here is that most copy events thus far are using just the browser and the DOM, and there's something clever happening with data that you have on the local machine rather than data you have remotely. And it's important that we can go to that remote data, because you really don't want, every time you select the whole spreadsheet, 300 milliseconds later, for it all to be shoved into your client. That would really not be clever, would it? So it's really important that we can catch those events and do a good job. The other thing that really is unpleasant is printing. So ignore the fact that it would be really nice to know what printers are attached to your machine, what paper sizes, what paper tray sizes, what, you know, feed options they have in them, what kinds of paper. I mean, forget that. That's obviously unrealistic. But just being able to actually trigger the printing dialog would be quite nice, you know? I mean, I have sympathy with the idea that the JavaScript shouldn't be, you know, printing stuff out in your basement, you know, so when you browse to news.com or whatever, you know, some huge advert is printed on your, you know, your paper automatically. That's fair enough. But at least, you know, having some direct access to the print dialog would be really, really rather helpful. And the nice thing is, of course, that PDF is the obvious mechanism here, and browsers are typically very good at PDF these days. And we use it as our CUPS meta-file format on Linux anyway, so we're good at making PDFs. And, you know, well, they'll probably get the page sizes sorted out somehow, and the envelope labels might match up anyway if you're lucky. But yeah, just it would be nice if we're able to print. Chrome has an extension, I think, here that helps significantly. I think Mozilla doesn't. Ah, cool. So I just do what my slides say. So let's see if we can do something fun. What was this one? Basic presentation. Here we go. So one of the things that we can do is that we can start to download this file in all sorts of different formats. So, you know, we can grab this thing as a PDF pretty easily. You can download it as ODP. We can do that sort of dynamic format conversion on the web, which is pretty nice. What else? Of course, there's all style editing, undo, redo. You probably don't want to see any of that. Now, what does this thing do? Help. If you need help, you can get it there. There's a good button you can press which does a nice thing for slide presentation. So it converts your slideshow or to SVG and then shoves it to you so that you can you know, walk through it. And in theory, you can get transitions and fades and, you know, pictures of lovely things and, I don't know, all this sort of text animation. And we're doing quite well. Look at this shape's change color. Look at that, you know. Have you ever seen? Have you ever tried to change a shape's color while you're animating it? You know? So this is actually rather ahead of what the alternatives out there are actually able to do. In fact, it's quite a pitiful set of transitions in some of the alternatives. So, you know, they can't turn those things arrows around as they're going, you know, this sort of thing. So that's pretty fun. And what else can we do? Oh yeah, let me show you a nicer, more advanced spreadsheet, because, you know, I'm going to mark us up. Where are we? Basic spreadsheet. You know, so we have here there's some nice examples of, you know, text doing funny things and strikeouts and number formats, and, you know, so it's a real spreadsheet. It's not just a, you know, load it and hope spreadsheet. It's not a show you the cached answer spreadsheet. It's a let's actually try and do the calculation right and do a good job of it spreadsheet, which is nice, you know. So you can hopefully get a really high fidelity view of what you've got there, and do then some minimal editing with it. Obviously, as I said, it's not a incredibly full-featured editing suite yet. What else? Aha, yes. Is that I'm. Okay, deeper down. So I'm supposed to show you this. So we're looking at collaboration. Obviously, collaborative editing is a vital thing on the web, and you know, people sort of associate it with online office suites. And I'll show you some of how we're going to do this in future. But I'll just show you the limited shared editing we have at the moment. So this effectively then gives you a single cursor, so that you can. This is a Chrome and a Firefox on separate sides, so you can see I'm not cheating. I have 10 minutes left. Awesome. I should talk more quickly. You know, we can type you know, something beautiful in my daughter's birthday party thing here, and we can, you know, make the text bigger, and, you know, it's rendering effectively some quite nice custom art thing. And as you can see, the jaggies quite vigorously here that I hope will be Cairoized very shortly when we do this again. So that's pretty nice. And of course, just so you get the right idea, we can come over here and say, shared love or something like this. So that's all good. So shared editing is the basics of this, but I'd quite like to show you the what we're going to be doing for non-collaborative editing. So, for example, at the moment, this is my presentation, and it's relatively easy to create a new window. And if you go home and play with this, you'll discover that this actually provides multiple cursors, multiple entry points, multiple selections, and is an underused feature. So I think we can expect lots of interesting improvements to come out of this work, but at least the feature conceptually is there. So here's some random statements that I'll waffle over. Please do read them from cool people who are doing things and supporting work, particularly iSwarp, who have helped substantially fund a lot of this work. And this is kind of awesome vision for a company. I love it. OwnCloud, obviously, I've been demoing you the OwnCloud integration there, which builds on top of work actually done by WebODF people, but free software is great. Colab, we announced yesterday a partnership with to take this to market, and obviously we hope to have many more. We want to get this thing out there. There are lots of people who've actually done the work that are not me, and many heroic names here. Most of them Collabora, sadly, so far. We're trying to fix that problem by getting people involved, so it's very easy to get this thing. All the demos that I showed you today are there, except my daughter's party invite. So, you can just download it now, zip it update, and get it and play with it on your own device pretty trivially. And you get that OwnCloud, Collabora Online, and OpenSUSE piece there. And, send us some patches, send us some feedback. The way to get involved is just go to the normal public dev list for LibreOffice, clone the software. It's pretty much all there. And, just the normal way to get involved with LibreOffice. And there's lots of things we'd love people to do. This is a feature I'd really like. It's a latency simulator. Something that reads data and doesn't give it to you for another however long you like, 10 milliseconds, 1 millisecond. So we can, more easily test with a defined ping on a local machine and make sure our developers are really, experiencing the joy of being on the other side of the world, just the physics of being somewhere else. A JavaScript, bridge would be nice for scripting. Here's one of the things that was said to me yesterday. So one of the problems with open document formats and LibreOffice generally has been getting people to have software that will support it well. And there are many routes to try and fix this, encouraging vendors to implement good ODF support. But one of the beautiful things about LibreOffice Online is that it makes it possible to have that good support everywhere. So you can render your ODF and you get a really good result. And so without needing to do anything to your PC or mobile device, without installing anything. And so when the next lame person says, I couldn't open your document, you go, well, did you look at the link in your email that said, it's over there? Just, let me help you click on the browser, let me plug your mouse back in, which is cool. So hopefully that'll help. I'm just going to flick through these very, very quickly. There are lots of people who've done great work. Cloud integration of remote files, obviously very important. So, being able to talk to different kinds of servers. Android own cloud integration is obviously there for a while, but worth noting there have been several improvements in the Android version 2 for this 5.1 release coming out just after FOSDEM. Lots of improvements in mail merge embedding, a formula wizard. ICA has done amazing things to the table syntax and Excel calc core, let's say. But they're not screenshotted, so they're not on the screen. I'm sorry about that. Better statistics dialog, ping, export, and calc, search, lots and lots of lovely things. Lots of user experience improvements to make it easier to use. Better stuff in Impress. New OpenGL transitions that are interoperable and pretty. MathML, cut and paste. Keynote 6 support. They completely changed their file format, I understand, so we had to, redo this, thanks to David Tarden. Lots of work on OpenGL to accelerate rendering and make it snappier. Menu bars have been substantially reorganized, so you can retrain yourself into the new world. Sidebar has been improved by all sorts of good people. Lots of new features there. I think there's a chart sidebar now, so you can edit your charts from Marcus, but lots of other little bits of cleanup all over the place in the sidebar. So, lots of nice stuff. So, LibreOffice is getting better. It's awesome. And there was a huge amount of stuff done in the last year. And I'd like to tell you progress is accelerating. More and more people are interested. They want this thing. I think the online piece is extremely exciting for many. just getting access to that functionality, and in a way that gives you, those privacy guarantees that, you can control it and lock it down and make it securely your own. So yeah, if you're interested in helping out, grab me or others on IRC. That's a great way, or just mail me a thing in the slides. So you've been very patient and good. Thank you for your time. Do we have time for questions?
Are there any questions?
Are there any questions? Awesome. There's a gentleman over here. You get a free sticker with every question asked. Well, I know. Yeah. They're queuing in the back to get in, just for the stickers. Excellent.
So if you use tile rendering to render your document, how does it work with screen readers?
Yes, that's a brilliant question, and I was hoping you wouldn't ask that one. So I think if you are someone that is visually impaired, for example, the great thing is that you're going to need customized technology to deal with your impairment. And I would strongly recommend that one of those customizations would be using the PC version and downloading the file out of OwnCloud, using the OwnCloud integration, and then using it through that means. I think that's a better way to get an accessible experience. So yes, I mean, that's the trade-off that you take from having a high-fidelity rendering model like that. So, good question. I love it. Is there another good question? Ah, yes.
Hi.
Hello.
Will any of the performance improvements from the online version benefit the desktop application?
Yes, of course. And I'm excited about that because I have a passion for making things faster and hopefully not breaking them at the same time. That's my goal. And the beautiful thing about this is that there should be hosters everywhere that start to have a financial incentive to optimize LibreOffice. So you may think that the world is about, programmers, doing things for fun, and it is. But if we can provide a virtuous circle where there's a financial incentive to improve something, then my hope is that we get a lot quicker and better. So yeah. I'm loving it. If you want to make it faster, come and see me. I'll help you. Jeff. You're going to tell me there's about 3 web APIs that do exactly what I want,
No, I'm not, actually.
Oh, cool, good.
It seems to me that the big advantage of doing the tiling method as opposed to building an entirely new UI in HTML, which, as I understand it, is what the 2 main competitors have done, is that you can provide a richer editing experience because you're not as limited by web browsers.
Yeah, so there's a large degree of truth in that. I think our main competitors, so I think Microsoft is using quite a similar model to us.
So they're using tiles, because Google Docs is definitely HTML
that's right.
widgets.
But if you look at Office
360 something. 366 this year, they're calling it, I think.
Yes. Anyway, Microsoft are doing a great job. And they have a similar problem, but on a bigger scale, I think, in terms of the deep legacy code base. I guess Zyka talks about it in a talk online. So, but I think, at least for the WYSIWYG, they do pagination and preview for Word, for example, and it looks pretty bitmappy to me. Mm-hmm. But yes, I mean, so we do get that high fidelity, we get the, weird, exotic language support. So, if you have a very minority language with 10 people using it and it's got weird glyphs and horrendous shaping problems, assuming that it's on the server and it works fine, it'll work everywhere on every device. We can do the mixed language spell checking, and all of those weird line breaking and hyphenation things and get, just really good fidelity end to end. But of course, at the sacrifice of, you then need to use the API to introspect the content.
So that was an initial observation. There was a question coming.
Oh, sure. But let me point out that it's not completely hopeless with accessibility. You should be able to get your cursor position and integrate those events, assuming you can do those round-trip calls you're going to need to do in the callbacks inside the browser, assuming there are any callbacks. But from what I see of WebAria, it looks very much like just annotation, which I think is a bit lame. I think web could do better.
Yeah, I certainly think you would have difficulty building a client-side accessibility shadow DOM out of what you're doing.
It would not be fun, let's say. Yeah.
So the question is, as we know, web browsers suck and they're clearly limiting what you're trying to do. Have you sort of had conversations with or filed debugs about the remaining things which are tying you to the ground and preventing your rocket from reaching the stratosphere?
I know.
That us terrible web browser makers are
limit at the top.
limiting you with our terrible software.
No, but I'm very happy to talk to any browser people who happen to be here. So that's great. Come and harass me at the end, and we can connect you to the people who've suffered, the ignominy of a poor solution there. So yeah, I mean, we'd love to work together and make it better. That's the thing. Thank you. Are we out of time yet?
Well, perhaps there's time for one last question.
One last question. Oh, there's a hand over here. Go for it, sir. Oh, no, there. Oh, I always like to hear from Jos. It's great. Go for it, dude.
So, relating to the copy-paste and also the accessibility,
Sure.
if you look at the way a PDF is rendered in, for example, Firefox, what they do is they take text and put it invisibly, so with 0% translucency, 0% opacity, on top of the other text.
Right.
So that you can actually select something which is invisible, and it's actually in the copy-paste buffer automatically. So you don't need to do your Ninja in the 300 milliseconds. Did you look at that?
Except it works really badly. So if you try and copy and paste stuff out of pdf.js, you'll find a lot of spaces in there that you didn't expect. I certainly find that. Yeah, sorry about that.
So yes, I think there's an increasing number of elite hacks we could do to make everything better. But I think probably getting the infrastructure right in the first place would probably save us all a lot of hassle, particularly when you start looking at the JavaScript library that tells you whether you have this feature, and it's just this madness of checking versions and doing stuff already. I think we should probably try and avoid that.
Feature detection.
Yeah. So, yeah. Thank you very much. You've been very good.